You know what time it is?
Time for redox.
You always do that. You always just like ruin my moment that I'm going to have. Okay, it's time for redox reactions. Okay, so let's talk about what redox reactions are. What in the heck are they? So let's start by looking at a reaction that we all know very well, and that would be, that would be aluminum plus copper 2 chloride. How about I just go ahead and balance this ahead of time? Yields aluminum chloride plus copper. I've seen this a bunch of times, right?
Yep.
It's a single replacement reaction, but it is also a redox reaction. And redox stands for reduction, oxidation. Redox.
Okay.
So that means that something is reduced and something is oxidized.
Okay.
Now, what does that mean?
This is based on transfer or migration of electrons.
Okay.
So we're going to see a change in oxidation numbers.
Change in oxidation numbers, going all the way back to that. Awesome. So what we have to know is that something that is reduced gains electrons, right? And then something that is oxidized loses electrons. And I'm going to give you a mnemonic that you can use later on in the video. So if something gains electrons, its oxidation number goes down.
Okay.
If something loses electrons, its oxidation number goes up.
Okay.
There's no sound effect for that. Right. Let's then look at this reaction. So if we're looking at the oxidation numbers of everything in this, so let's write them on top of everything.
Okay, so aluminum, since it's an element by itself, starts at 0.
Okay. Elements by themselves are just 0. No oxidation number.
Okay, copper is plus 2.
Okay, this is copper 2, so it's plus
Stock
2.
metal.
Okay.
Chlorine is minus 1.
Okay.
Aluminum is plus 3. Chlorine is minus 1. And copper, again, by itself is 0.
Okay, so we knew that copper in copper 2 chloride was copper 2 plus 2 charge. The chlorine's minus 1. Okay, so let's look here and see what changed. Whose oxidation number changed from one side of the reaction to the other?
The aluminum and the copper.
Okay, so the aluminum's oxidation number changed from 0 to
Plus 3.
plus 3. And then the copper changed from plus 2. So, okay, you get the idea. 0. All right. So let's look at aluminum first. Aluminum went from 0 to plus 3. Did it go up or down? Did the oxidation number go up or down?
It went up.
It went up, right? So we lost electrons.
Right.
Lost 3 electrons. So therefore, we know that, I have a lot of arrows in here. The aluminum went through oxidation.
Okay. So it was oxidized.
So aluminum was oxidized. Now, the copper over here was reduced because it went from plus 2 to 0. Its oxidation number went down.
Okay.
It gained 2 electrons. So far, so good?
Yeah.
You want to do another example?
Sure.
Let's do something like, okay, let's do calcium plus,
Aluminum nitrate.
aluminum nitrate. I'm going to test my remembering of oxidation numbers. Okay, that's going to give us calcium nitrate plus aluminum, and then I'm going to have to do 3, 2, 2, 3. Okay, let's count. Let's look at the oxidation numbers of everything here.
Okay, so calcium
Everything.
0.
Calcium 0.
Aluminum is plus 3.
Plus 3.
Nitrate is minus 1.
Nitrate's
if you forgot,
minus 1.
check your chart.
Right. Calcium here would be
Plus 2.
plus 2. Nitrate's still minus 1.
Right.
And aluminum is 0.
Okay.
All right, so what was oxidized? What lost electrons?
The calcium.
The calcium went from 0 to plus 2, so calcium was oxidized. And then aluminum then went from plus 3 to 0, so therefore aluminum was reduced. Okay, that's pretty easy, right?
Yep.
Anytime you see a reaction in which you have some oxidation numbers that change, that means that is a redox reaction. So some examples of types of reactions that are also redox reactions. We know we have single replacement reactions
Yep.
are redox. What else are?
So
Some
synthesis,
some synthesis reactions,
decomposition,
some decomp reactions, and even
combustion.
some combustion.
So not double replacement because you'll see that the oxidation numbers stay the same. They're just changing partners.
Okay, so great.
So what's the acronym to remember?
Now the fun part, right?
I
So
know two of them.
I know two of them as well. So we have oil rig, which is oxidation is loss of electrons. Rig is reduction is gain of
Easy
electrons.
enough.
But my favorite, my personal favorite, is Leo goes grr. Right? That means lose electrons oxidized, gain electrons reduced. Leo goes grr.
I like that one better too.
Perfect. Now you got it.